Okay, we've been working on reading for important information. So today I'm going to give you an example of a topic. And the topic that I've chosen, imagine this, is the ocean. So I'm going to get it to read to us because it saves Mrs. Spivey's voice. We're going to start here.
Ocean is a great body of water that covers nearly 71% of Earth's surface. People also call it the sea. The ocean contains 97% of all the water on Earth. The ocean serves as a source of food, energy, minerals, and recreation. Ships sail the ocean to carry cargo between continents. The sea also plays a major role in Earth's climate system by regulating the air temperature and by supplying the moisture for rainfall. If there were no ocean, life could not exist on our planet.
Wow, that's pretty important. Life would not exist on our planet. All right, so the first question is, what are its physical properties? How can it be described? It's a great body of water that covers 71% of the Earth's surface. So this is typed in for you. Notice if I go back, it says it right here. It's a great body of water that covers 71% of the Earth's surface. So everything I'm taking and I'm putting in my organizer is coming from the text. So the next question is, we can scroll up, how does it work or function? And again, it tells us in this paragraph right here, the ocean serves as a source of food, energy, minerals, and recreation. Ships sail on it, and it plays a big role in our Earth's climate. So if you look back here, it says, oceans are a source of food, energy, minerals, and people use the water for many types of sports and other activities. That's another way of saying recreation. So I can actually type that in there. It's another word for, so fun activities, another word of for recreation. Ships sail across it for various reasons, and it regulates the climate on Earth. Okay, so the next question says, what are they made of? How are they made or formed? Well, that's a big question, and I know that there's some answers there, but we're going to go ahead and listen some more. We're going to start, hopefully.
The ocean serves as a source.
There we go.
The bottom of the ocean has features as varied as those on land. Huge plains spread across the ocean floor, and long mountain chains rise toward the surface. Volcanoes erupt from the ocean bottom, and trenches and valleys plunge to great depths. Scientists called oceanographers work to discover the ocean's secrets. They study how the ocean moves and how it affects the atmosphere. They investigate the chemical composition of seawater and monitor the various forces that shape the seafloor. They also study how organisms live in the sea and how people have affected the ocean.
All right. So I know that our question is, what are they made of? So it's what is the ocean made of and how is it made or formed? But really that part answers who studies, discovers, or invents. And then the answer would be oceanographers. Okay, that one was kind of, that one's an easy one. But sometimes our text isn't organized the way that our questions are. So we have to be aware of our questions and be aware of how the text is organized. So, you know, you got the oceanographers part, but you didn't get this part yet. So we're going to go back and we're going to listen some more. So now we are at the world ocean. Whoops.
The ocean forms one great connected body of water often called the world ocean, or the global ocean. The continents divide the world ocean into 5 major parts. They are the Pacific Ocean, the Atlantic Ocean, the Indian Ocean, the Southern Ocean, and the Arctic Ocean. Each ocean includes smaller bodies of water called seas, gulfs, or bays, which lie along the ocean margins. For example, the Caribbean Sea and the Mediterranean Sea are part of the Atlantic, and the Bering Sea and the South China Sea are part of the Pacific. The word sea also refers to the ocean in general.
All right, so let me break this down. It says that there are 5 major parts of the ocean. We've got the Pacific. So if you've ever been to California, that's where that is. The Atlantic. So if we go to Virginia Beach and we put our feet in the water, that's where we're putting it, in the Atlantic Ocean. Okay. Then we have the Indian Ocean, which is across the world. It's definitely to the east of us. The Southern Ocean. This is, think about Antarctica, the bottom of the world. That's exactly where it is. And then we've got the Arctic, which is at the top. All right. And then it includes smaller bodies of water. We've got seas and gulfs and bays, and we know that. We live near the Chesapeake Bay. All right. Then smaller parts are called the seas, the Caribbean Sea, the Mediterranean Sea, the parts of the Atlantic, and the Bering, South China are parts of the Pacific. So it also refers to the ocean. So basically it's all tied together, although we kind of separate it into parts. All right?
The world ocean contains about 97% of all the water on Earth. Most of the remaining water occurs frozen in ice sheets and other ice formations. The rest is underground, in the air, or in such bodies of water as lakes and rivers.
All right, so
Area. The world ocean covers.
Stop. The world ocean contains 97% of the water on Earth. So the lakes, the rivers, and all of those things, those are going to be in the 3%. So the ocean covers 97%. So if I go back to this question, it says the bottom of the ocean contains, the bottom of the ocean contains plains and mountains. But there's, I'm sorry, right here. The ocean is made of water and contains about 97% of the Earth's water. So now we're going to listen to area. And this is going to give you guys the breakdown of the Pacific, the Atlantic, the Indian, and so on. Okay? I'm trying to see the oceans and trenches. Oh, okay, right here. It tells you what it's made of. Plains, long mountain chains, volcanoes are at the bottom of the ocean as well. All right, we're going to start with area.
Area. The world ocean covers about 71% of Earth's surface. Most of the ocean lies in the southern hemisphere, that is, south of the equator. The southern hemisphere consists of about 80% ocean, and the northern hemisphere, about 60%. The Pacific Ocean ranks as the largest ocean by far. It covers about 66 million square miles, 171 million square kilometers, about 1/3 of Earth's surface. Near the equator, the Pacific stretches about 11,000 miles, 17,700 kilometers, from Panama to the Malay Peninsula. North and South America border the Pacific on the east, and Asia and Australia lie to the west. To the north, the Bering Strait links the Pacific with the Arctic Ocean. See Pacific Ocean. The Atlantic Ocean covers about 34 million square miles, 88 million square kilometers. Europe and Africa lie east of the Atlantic, and North and South America lie west. See Atlantic Ocean.
Virginia Beach is on the Atlantic Ocean.
The Indian Ocean has an area of about 26.6 million square miles, 69 million square kilometers. Africa lies to the west. Australia and Indonesia lie to the east. Asia borders the Indian Ocean on the north. See Indian Ocean. The Southern Ocean covers about 8.5 million square miles, 22 million square kilometers. It surrounds the continent of Antarctica. See Southern Ocean. The Arctic Ocean covers about 3.7 million square miles, 9.6 million square kilometers. It is bounded by Asia, Europe, and North America. See Arctic Ocean.
All right, so now we've gone over the oceans. We've gone over the Pacific, the Atlantic, the Indian, the Southern, the Arctic Ocean. Now it's going to talk, again, physical features. It says, what are they made of? So if you look at your headings, depth, temperature, composition. Composition is another word of what it's made out of. And then it goes into another heading, the importance. So again, you're going to get information in this section right here. What are they made of? How are they made or formed? So let's listen to, going back up, depth.
Depth. The world ocean has an average depth of 13,000 feet, 4,000 meters, but parts of the ocean plunge much deeper. The deepest areas occur in trenches long, narrow valleys on the seafloor. The deepest known spot is in the Mariana Trench, in the western Pacific Ocean, near the island of Guam. It lies 35,840 feet, 10,924 meters, below sea level. If the world's highest mountain, 29,035 foot, 8,850 meter, Mount Everest, were placed in that spot, more than 1.3 miles, 2.1 kilometers, of water would cover the mountaintop. The Java Trench is the lowest point in the Indian Ocean. It lies 23,812 feet, 7,258 meters, deep. The deepest point of the Atlantic lies in the Puerto Rico Trench, at 28,232 feet, 8,605 meters, below the surface. In the Southern Ocean, the deepest point exists 23,737 feet, 7,235 meters, below sea level, at the southern end of the South Sandwich Trench. The Arctic's deepest point lies in a deep plain north of the islands of Svalbard, and measures 15,305 feet, 4,665 meters, below sea level.
All right, so it just tells you about the depth of the ocean. Let's see. Okay, the bottom of the ocean contains plains and mountains, much like the land surface that we can see. There are 5 oceans, we've talked about that are basically all connected, which is also true. But it divides the world in 5 major parts. The ocean is made of water and contains about 97% of Earth's water. There are deep parts of the ocean. Just told you that. The Mariana Trench, the trench in Puerto Rico. And now we're going to look at temperature. Okay, it's warm during the summer, but let's see what it says about temperature.
Temperature. The surface temperature of the ocean varies from about 28 F, 2 C, near the North and South Poles to about 86 F, 30 C, near the equator. In the polar regions, the surface seawater freezes. The western tropical Pacific has the warmest surface water. Ocean currents affect the surface temperature. Some currents carry warm tropical water toward the poles. Other currents bring cold surface waters from the poles toward the equator. Ocean temperature also varies with depth. In general, the temperature falls as the depth increases. The warm surface waters extend to depths of about 500 to 1,000 feet, 150 to 300 meters. Below the surface waters, the temperature decreases rapidly, forming a layer called the thermocline. The thermocline varies in thickness from about 1,000 to 3,000 feet, 300 to 900 meters. From the thermocline to the seafloor, the temperature decreases more slowly. Ocean temperature ranges between 34 and 39 F1 and 4C near the bottom. In some regions, colder and deeper water rises to the surface, lowering the surface water temperature.
Okay, as you go deeper in the water, the temperature decreases. Think about it though. Your sunlight is only affecting the top part of the ocean, and if you go deeper and deeper, if you get into some of those temperatures, it's going to be extremely, extremely cold, and it's going to also be dark because you can't see anything down there. So again, I put the ocean is made of water, contains about 97% of the Earth's water. There are deep parts of the ocean. That is basically just summing it up. It gives more detail, but the reader just needs to know, or you just need to know for your notes, that there are very deep parts of the ocean, okay? And you could probably put in there that some of these deep parts are called trenches. Let's look at composition, what it is made out of.
Composition. The ocean likely contains every natural chemical element, but the sea is best known for its salts. On average, the weight of seawater contains about 3.5% salts. 11 ions, or molecules with electrical charges, account for the ocean's salinity, saltiness. They are, in order of concentration, chloride, sodium, sulfate, magnesium, calcium, potassium, bicarbonate, bromide, borate, strontium, and fluoride. The most abundant form of salt consists of the ions sodium and chloride. Many ions in the ocean come chiefly from the dissolving of rocks on land. As rocks break down, rivers carry the resulting ions to the ocean. Volcanoes and undersea hot springs also contribute ions to the ocean. Evaporation and precipitation further affect ocean salinity. Evaporation removes fresh water from the ocean surface, leaving behind the salts. Precipitation, however, returns fresh water to the ocean. Evaporation in subtropical areas is greater than precipitation, so these areas have especially salty surface waters. Closer to the equator, precipitation is greater than evaporation, making surface waters less salty there. Rivers also bring fresh water to the ocean, which lowers the salinity of seawater near river mouths. The important...
Stop. All right, we're going to go back here. It says it varies in temperature and what it's made out of, the composition, okay? And again, it's not only water, but it's also, there we go, salt. Not solly, but salt. So now the importance of the ocean. If you look at that last box there, it says, how does it affect me? We already know who studies it. How does it affect me, helpful or harmful? Okay, so that's where we are with this part.
The importance of the ocean. As a wealth of resources, the ocean provides many major resources. They include 1. Food, 2. Sources of energy, 3. Sediments, and 4. Medicines.
Stop. So the author right here is giving you basically the answer, and they're going to go into some detail, but we're going to listen to those details.
Food from the ocean consists mainly of fish and shellfish. Most of the catch comes from coastal waters. The world's fishing fleets harvest many kinds of fish and shellfish. The chief kinds include anchovies, haddock, herring, lobsters, mackerel, oysters, sardines, shrimp, and tuna.
All right, so anchovies, haddock, herring, mackerel, those are all types of fish.
Food from the ocean consists mainly of fish.
It's going to read it to you. The fishing industry also is harvesting less familiar types of seafood and developing new products and markets for the catch. Right here. For example, surimi, a fish product developed in Japan, can be made into imitation crab, lobster, scallop, and shrimp. Processors use a wide variety of fish not traditionally eaten, including certain species of flounder, to make protein powders for enriching foods. So some people that don't eat a lot of meat, they might need protein. So this is how they're developing their protein. So now we're going to start at seaweeds.
Seaweeds also serve as a source of food, in addition to having industrial uses. Kelp, a large seaweed, is one of the most important. Kelp contains such nutrients as iodine and potassium. However, its chief value is as a source of algin, a thickening substance used in making ice cream, salad dressing, cosmetics, and many other products. People farm the ocean much as they farm the land. In a type of farming called aquaculture or mariculture, farmers raise fish, shellfish, and seaweeds near ocean shores as well as in ponds. They use special methods to make the animals and seaweeds grow faster and larger than they would in the wild. Fish hatcheries, a related management technique, produce healthy young salmon and other young fish for release into the ocean.
So far, people use the ocean for food. Okay, next, sources of energy.
Sources of energy from the ocean have several forms. Petroleum and natural gas rank as the ocean's most valuable energy resources. Offshore wells tap deposits of oil and gas beneath the seafloor. Today, about 30% of worldwide oil and gas comes from offshore production. Scientists think that there are huge reserves of oil and gas still remaining beneath the ocean floor. As gas and oil reserves on land are used up or become too difficult and expensive to attain, undersea deposits will become increasingly important. The ocean tides also provide energy. Tidal power facilities use the energy in the rise and fall of the tides to produce electric power. Unlike petroleum and gas, this source of energy is renewable. The first tidal power plant opened in 1966 on the Rance River near St-Malo, France. Ocean waves also provide potential sources of renewable energy. Sea energy supply, water power.
All right, so now we're going into sediments. What are sediments? It's the little teeny types of material, and it's deposited at the ocean floor. And you're going to really need to know this when it comes to volcanoes and the rock cycle.
Sediments are materials deposited at the bottom of the ocean. Ocean sediments collect sand, mud, minerals, and other materials. Important sediments recovered from the ocean include sand and gravel mined from the seafloor and used to make construction materials. People also use some sand to restore damaged beaches. Seawater itself contains such important minerals as bromide and magnesium. These minerals can be removed by letting seawater evaporate in large shallow basins under sunlight. The evaporation leaves the mineral deposits behind in the form of salts. The salts themselves and such elements as magnesium and bromide can be extracted from the deposits. Other methods to remove minerals from seawater include chemical and electrochemical processes. The mineral wealth of the ocean extends to the deep sea floor. The deep sea floor contains vents from which hot water flows. Deposits at these hydrothermal vents contain copper, iron, and zinc. But mining the ores would prove expensive and difficult, and the techniques must still be developed. Manganese deposits lie on the ocean bottom in lumps called nodules. The nodules also contain valuable amounts of cobalt, copper, and nickel. Possible techniques to mine these nodules include using buckets that run on conveyor belts between a ship and the seafloor, or operating a device that works like a giant vacuum cleaner.
A vacuum cleaner, not a vacuum cleaner. All right, so how does it affect me? People use the ocean for food, sources of energy, sediments, sand, and then the next comes medicine. So what kind of medicines can we get from the ocean?
Medicines may be produced from many forms of marine life. For example, plant-like organisms called red algae could provide anticoagulants, drugs that keep blood from clotting. A family of marine snails produces substances that may treat pain. Sea life has also aided medical research. The blood of horseshoe crabs contains a substance used to test for infections and bacteria contamination. Researchers study nerve cells from lobsters, squids, and marine worms to learn more about how the human nervous system functions. Other products from the ocean include coral, pearls, and shells used in jewelry. Many people believe that natural sponges from the ocean bottom are of higher quality than synthetic sponges. In many dry areas near sea coasts, people desalinate, remove the salt from seawater to produce fresh water for drinking and industrial uses.
All right, so they think that they have the sea sponges, natural sponges have better quality than synthetic sponges. Synthetic means man-made, like the plastic ones that you get from Walmart, okay, the different colored ones.
As an influence on climate, the ocean helps stabilize Earth's climate. The ocean's great size and the slowness of water to change temperature have a steadying influence on the temperature of the atmosphere. In summer, the ocean stores heat from the sun. In winter, when the sunlight is weaker, the ocean releases the stored heat into the air. Currents carry the heat of tropical waters toward the poles, thereby cooling the tropics and warming the polar regions. The ocean is the source of most precipitation that falls to the earth. The sun's heat evaporates water from the ocean surface. The water rises as invisible vapor and forms clouds as it cools. It then falls back to the earth as rain, sleet, hail, or snow.
All right, so
as a vast highway,
woo.
The ocean has been a highway.
Hey, you need to listen. All right, so medicines, climate, we just talked about all of that up here as an influence on climate and how it stabilizes Earth's climate. Last is a vast highway.
As a vast highway, the ocean has been a highway for trade since people built the first ships thousands of years ago. Shipping ranks as an important use of the ocean in international trade. Sea ship transportation.
All right, so as a vast highway, does that mean that it's actually a highway that you drive upon? Obviously not. It's talking about ships and how they're still trading and importing goods, okay? In fact, Virginia is one of those ports. So down here it says climate and travel. So now I've listened to this entire piece and I have answered my questions. What, how, what, who, and how again. This is how to organize your thoughts when it comes to topic, and the topic being